In this video, we will discuss uncertainty and proportional error. These ideas are important because measurements are never perfectly exact. This does not mean measurements are wrong. It means every measuring tool has a limit. A ruler, a stopwatch, a balance, and a thermometer, all of these have some uncertainty. Think about this. If two people measure the same object with the same ruler, will they always get exactly the same number? Maybe not. Their measurements should be close, but small differences are normal. Uncertainty tells us the range within which the actual value is likely to fall. For example, if we write L equals 12.5 plus or minus zero point 0.1 centimeters, that means the measured length is 12.5 centimeters, but the actual value may reasonably be about zero point 0.1 centimeters higher or lower. The uncertainty is not a mistake. It is part of honest scientific reporting. A measurement without uncertainty may look more precise than it really is. So when we write down a measurement, you first write down the measured value and then you put plus minus sign and then you write down the uncertainty and then you put the units. So the uncertainty of a measurement depends on the instrument that you are using. And to indicate the uncertainty, we use if you are making a measurement, let's say a measurement of A, then uncertainty is indicated using delta A. And if your measurement is not so accurate, then the uncertainty of the value will be higher. Sometimes the absolute uncertainty alone does not tell the whole story. We also need to compare the uncertainty to the size of the measurement. Proportional error compares the uncertainty to the measured value. It tells us how large the uncertainty is relative to the measurement. The formula is the proportional error of a measurement is equals to uncertainty divided by the measured value. If we want percentage error, then we multiply this proportional error by 100% and we get the percentage error. This is useful because the same absolute uncertainty can be important in one situation but not very important in another. For example, an uncertainty of 1 centimeter is large if you are measuring a pencil, but very small if you are measuring a football field. If you have two measurements, let's say 10.0 plus minus zero point 0.1 centimeter, and another measurement, let's say 100 plus or minus zero point 0.1 centimeter. From these two measurements, which measurement is relatively more precise? So we can say this measurement is relatively more precise because the second is precise because the same uncertainty is smaller compared with the measured value. Here we have a higher value measured compared to here, so the proportional error in the second value is smaller compared to the first one. Now let us apply this idea in an example. When we calculate the proportional error, first we have to identify the measured value, and then we have to identify the uncertainty of that measurement, and then we divide the uncertainty by the measured value. Now in this example, the length of a block is measured and the result is expressed as L equals 6.230 plus minus 0.005 centimeters. Calculate the proportional error in the block's length. So here the measured value is this 6.230 centimeters and the uncertainty of the measurement is 0.005 centimeters. So if we calculate the proportional error, it is the uncertainty divided by the measurement. So 0.005 centimeter divided by the 6.230 centimeters. And as you can see here, these units are cancelling out. So our final answer do not have any units. So proportional error do not have units. And if you notice here, the number in the numerator has 1 significant figures and the number in the denominator has 4 significant figures. So in this division, the least amount of significant figures is 1. So our final answer should have only 1 significant figure. So for this problem, our answer is 0.0008. Let us summarize the video. Every measurement has some uncertainty. Uncertainty gives the possible range of the measurement. Proportional error compares the uncertainty to the measured value, and percent error expresses the comparison as a percentage. Now this completes our introduction to physical quantities. The main tools from this set of videos are units, unit conversion, significant figures, uncertainty, and proportional error. These tools will support almost every physics problem we solve later in the course.